Hey folks, it's Leo. Welcome back to the channel. This is my desk build video part 2. In part 1, if you haven't seen it, I recommend you pause this video, go back and take a look. Part 1 is more of a desk tour. It lets you know what the desk is all about, what some of the key features of the desk are, and how it connects to the rest of the studio here. In this video, what we're gonna do is actually talk about how I built this desk, as in what were the requirements, how did I design it, how did I cut all the pieces, how do they fit together, this kind of stuff. I wanted a place that is inspiring to work. I'm not gonna go through all the trouble of making a desk only to have it be a boring place to sit and do work. I'm personally inspired by things like NASA flight centers, power stations, recording studios, even old-timey telephone call centers. I'm also inspired by fine furniture. Don't judge me. I went to the Getty Center in Los Angeles as a kid, and they have a fantastic collection of furniture there, and I developed a lifelong fetish for good furniture, particularly mid-century modern. I think that is some of the best looking furniture, so I want something like that. Small. I want it small. Small is beautiful. I want something platform-like, just smaller. I want to use the existing IKEA legs that I already have if possible, not because I love IKEA, but because I already have the legs. As I was thinking about my needs, I realized that I don't mind having my 19-inch gear in the rack over there. Once I set that stuff, I usually never have to touch it again, so if I set my preamp levels or patch bay points, I don't need to fidget with that all the time. What I do like to play with is all the gear in my Eurorack system, and so I would much rather have my Eurorack gear up here where I can easily reach it and touch it and play with it, and leave the 19-inch stuff racked up. Ergonomics is king. I want to be able to access all of my gear easily without having to reach all the way over and get out of the sweet spot. I want my speakers at ear height. I want to be able to pull out my keyboard and play if and when I need to do that, otherwise be able to push that in and have it be out of the way. Another thing I realized is I like these modules to be angled so that, for example, I can see the WaveRaiser screen easily without having to sort of bend down because of weird viewing angles. When I was building this desk, I already knew I was going to get these Genelec speakers that I have, the 8331s, and so I designed the shelf of the desk to be just deep enough to hold those up at exactly ear height. Decent cable management. I'm not super picky about cables, but I like to keep things as tidy as possible, so I decided this desk needs to have just the right amount of cable management to keep things tidy. For example, one of the ideas was that I will keep all of my power supplies and stuff tucked under the desk, which means if I have a situation where I want to have my laptop up, I can just plug it in, have it charged, no problems. I've also got other plugs down here that I've conveniently labeled. So, for example, my Memory Boy or my Eventide H9. So, if I want to do something with my Eventide H9, I don't have to go fidgeting with the power supply. I can just grab this, plug it in, and Bob's your uncle. I'm new to 3D modeling and CAD software, but I love it. Check this out. I took the model that was in my head and sketched out on some paper, and I turned it into this, a 3D model in Fusion 360. Now this is a pretty simple desk, but it still has lots and lots of little features. There's holes, there's pockets, there's cutouts, there's an aluminum bracket that needs to be added in. And being able to model all this is really cool because it means I can take, for example, the aluminum out and take a look at how all the pieces are going to fit together. I can measure things. So for example, if I wanted to know the spacing, how much wood is going to be there, well, I know that that's 9 millimeters, and that'll be plenty strong enough to support a screw holding up the rail for the Eurorack. And it doesn't stop there. This is not just a pretty 3D model that I can fly around and explore. Every one of these bodies, every one of these parts that I've created can actually be sent to a 3D printer or CNC machine in my case, so that I can cut them out. So I don't have to repeat this work and figure out how to actually make this once I'm done designing it in 3D. This is the actual part that's going to go into the CNC machine to be cut. Okay, so let's take a look at the desk itself. The desktop itself is pretty simple. It's a rectangular 1.5 meter by 72 centimeter piece of plywood. It's 24 millimeters thick. And as you can see, I've put some holes here for cable routing and cable management. This piece was cut for me by the wood shop that I bought the wood from. They very kindly offered to cut it for almost nothing, so I took them up on that. The top shelf, this bit right here, is 1.5 meters by 21 centimeters deep. I picked 21 centimeters because that's exactly how wide it needs to be to support the Genelec speakers. You'll notice I put out a little notch here so that the pole that holds up the monitor and the camera can go through it. And there's a smaller hole down here, a 10 millimeter hole, to hold that pole down to the bottom of the desk. One interesting thing about the top shelf is these little cutouts. I routed these out later with a hand router so that the shelf would fit more snug on top of the table. It looked a little bit chunky if you just put the whole thing on top. So taking out a few millimeters made it look a little bit more refined. And the most important bit of this desk, you could argue, is these 4 pieces of wood. So this holds the modules up and also holds the shelf in place. You can see I've got these end cheeks, which are a little bit thicker and have holes with little pockets in them, so the screw heads are flush with the surface of the desk. I think that's a nicer look. And on the inside, I've got these 2 pieces. Now you might be wondering, why are there holes in the desk? Well, that's for cable management and also to reduce weight. I wanted to be able to route cables and power and all kinds of stuff from this section here to the middle section and even all the way to the other end of the desk without having to run cables outside of the desk. I double checked to make sure that my power distribution boards would have enough space to sit here and that there was enough space here on the front for my sliding keyboard tray. I didn't model the keyboard tray, but it was a pretty simple, straightforward fit. Okay, so the cool thing about Fusion 360 is that when you're done designing your part, you can go over to the manufacture section. All right, so when you do that, you've got all your parts. I can turn these on and off here, but let's just focus on this cheek for now. Let's zoom in, and you can see here that you've got the cheek and then you've got all these things. These are your tool paths. So this is the way that the machine is going to move and cut your part. And if you take a look here, you've got a pocket right here, which is getting cut. And then you've got the pockets for the screw heads. And then you're gonna drill holes all the way through the part. And then you're gonna cut out the inside contour. This is so that the cables and things can pass through the inside of the desk. And finally, the outside contour. Every one of these things can be programmed. For example, I've got 2 millimeter passes, and that lets me get through this material in a number of steps rather than try to get it all in one pass. And you can see that here. Each one of these is a 2 millimeter step down as the machine works through the material. And not only that, you can actually simulate the process. So you can run a simulator and have your end mill actually work its way through virtual material, so you can make sure everything is looking good. And when you're happy with your part, you can click post process, and this generates the G code that you need to send to your CNC machine to do the actual cutting. So the machine I happen to own is a Stepcraft D-Series machine. This is a hobbyist DIY machine that I built myself. And it's really quite amazing what you can do with it. I mean, machines like this used to be gigantic and would cost tens, sometimes hundreds of thousands of dollars. But the fact that I can buy one of these for not that much money, fit it in a spare bedroom, and then learn digital fabrication using free software. Fusion is free for hobbyists, and it's really a golden era for makers. If you're interested in making things or learning how things are manufactured, it's really a wonderful time. Now you can see the machine pocketing out that space for the aluminum panel. I normally use a dust extractor on the machine, but I left it off so that we can see what the machine's doing. And you'll see me getting in there and vacuuming the dust away every once in a while. Now this cut took me about 10 minutes to do. And wood is generally not a problem for this machine. You can put any kind of wood you like in here and let the machine do its job, no problems. In a moment, you'll see me cut aluminum, and this is sort of new territory for me. It's taken several attempts for me to get good results with aluminum. I still don't think I'm quite there yet, but the fact that I can now machine things out of metal is really cool. Now with aluminum, you'll notice that I pause the machine every time so that I can vacuum up the chips. You'll see me do this over and over again. The reason I need to do that is because those chips, if they end up in that channel the mill ends up regrinding the chips over and over again, which causes them to melt and bind to the tip, and then you have some real problems. You'll break your end mill that way. So you have to get in there and vacuum it, or come up with other strategies to get good results. Here are the parts that came straight out of the CNC machine. I haven't touched these at all, so I can show you what's going on. You'll notice I've got some nice tabs in the back. That's so that when the part is being held down, it's being clamped down on the corners here and here. Once you cut through it, this is going to want to go loose, and if it goes loose, it might get in the way of your end mill, which is not good. That will most certainly snap your end mill and probably damage your work. So holding the part in the machine is a really important part of CNCing that a lot of people don't think about until they actually have to do it, and then you realize how important that is. Now, I screwed this up and I wanted to leave it in here so I could show you. I got a little bit enthusiastic with the cutting speed for making this video, and I think I overdid it. That end mill is spinning really fast, and as it moves through the material, you know, plywood is layers of wood glued together, and the very top layer got delaminated. Now, this is just for YouTube purposes, but if I was actually putting this in the desk, I would cut this again and go slower, or find some other machining strategy to get that to cut without these chipping. For my actual desk, I think I ran the machine at a slower speed, which generally gives you a finer cut and better quality. I think the end mill was newer too. You can see that the end mill is slightly worn because you're getting some of these fuzzies all along these edges. This is no problem. You can sand this down in a few seconds. It's really not an issue, but if you have a brand new end mill with razor sharp edges, it slices through the fibers of the wood and you don't get any of these problems. We've got to liberate this part that we want from the rest of the stock, and we're going to do that by getting these tabs out. And there's several ways to do that. What you can do is use a coping saw like this. This is a good method, but it's kind of a pain getting the blade on and off, and you have to do that if you want to get in there. And what I've found actually is that these saws, these work really well because these let you get into tight spaces. And so there we have it, our liberated part. What I'm going to do is sand the tabs down and also just give this a general sanding to give it a nice smooth look. And finally, we have the aluminum bracket. It still has the plastic cover on it. I'm gonna take that off now. So that looks pretty okay. That looks pretty okay. I should preface this by saying that I am not an expert when it comes to any kind of aluminum or metal milling with this machine. This is a simple part, and it's actually one of the first successful things I've milled. So I have a lot to learn. The surface finish here is not all that great. You can see it's got quite a lot of chatter on it. And what I really should be doing is using some kind of coolant, some kind of misting system or some kind of drip coolant to get a smoother, cleaner cut. I need to work on my feeds and speeds. There's a lot to be learned here, but the hole spacing is correct and this size is correct. As time goes on, I think I'll get better at this aluminum thing. So as parts come off of the machine like this, there's gonna be some burrs on here and these can be sharp. So what I like to do is take my deburring tool and just lightly run it along the edge to break any edges and make sure that there's nothing super sharp that's gonna cut me. Next up, to give this a nice smooth finish, what I'm gonna do is take some 120 grit sandpaper and just run this over that a few times. Let's take this and let's see if it fits. Nice, look at that. Okay, so that turned out really nice. It fits perfectly. You can see it's very flush with the surface. And I'm happy with that. The holes are aligned, everything is looking good. All right, and so here we have our parts, nicely sanded down. And you'll see all the fuzzies are gone, all the tabs are no longer there, and it's a nice looking part. So this is the outside cheek. So this and this are the same part. And the screws go through here and attach to the rails. And this is the inside cheek. So this one goes here, and screws go this way and attach to the rails. What we have here is an aluminum profile. This is what holds your modules in your case. Modules go like this. M3 screws go into that threaded bar that slides into this aluminum profile, and you bolt the actual profile using M5 screws right here into the sides of your case. Now, I mentioned in the previous video that aluminum is really easy to work with, and you're about to see what I mean. This is steel, so don't cut this with a table saw. You take this out and use a hacksaw to cut this. But this, I'm going to use my regular old woodworking table saw. I have a tiny table saw called the Proxxon FET saw. It's designed for making high precision small models, and it will sail through this like butter. Okay, so here's a freshly cut piece of the aluminum rail, and this is where the screw needs to go. Now, this is not threaded yet, but since it's aluminum, it's easy enough to thread. All you have to do is... And now you've got a threaded rail. So here's our bracket. The screw is gonna go, this is the back side of the bracket. I labeled it. And these are our countersunk screws. They need to go this way through the bracket to attach to these rods. All right, so check this out. We've got all the pieces cut and ready for making a miniature desk. So here's the end cheek, which corresponds to this. You've got the aluminum rails with the threaded rod on the inside. You've got the aluminum bracket on the side here with the countersunk screws. So this is basically the same as this section, just a little bit smaller. So here we have the middle section. This corresponds to this piece. The rails have been cut. These rails can be as long as you want them to be. And we have the threaded rod that slides in like that. We can actually put these two together so you can see how it all fits together, which is like this. So it's just like that desk, a little bit smaller. Now, you'll notice there's no screws holding this section to this section, because once the top goes on and you screw the top into the middle and end cheeks, this thing becomes captive. I've screwed it from the bottom of the desk into the sides as well. So once that's locked in, this whole thing moves as one unit, and it's not going to go anywhere. So with all these modules, you're going to need some power distribution boards to power the modules, and I built those boards myself. These are simple through-hole boards. I've made an entire video on how to do through-hole soldering, so I'm not going to explain that here all over again. I'll leave a link to that video. Once the boards were done, I mounted them to some scrap plywood. I put some pocketed holes so that the screws could stick through the wood, and I used brass spacers to act as standoffs so that the board wouldn't be physically touching the wood itself. I mounted those boards to the center section. I had smaller ones that I built for the left and right wings. When I calculated the power requirements of the desk, I realized I would need 2 RoPower 45 modules from 4MS. Those are powered by a 90-watt power brick, and those modules are hardwired to the power boards inside the desk. Now, before I plugged any modules in, I double and triple checked everything with a multimeter to make sure I'm not going to blow anything up, and I finally plugged everything in and switched things on. So if you've worked with any wood, you know that raw, untreated wood is a terrible idea. The first time you spill coffee on something that is untreated, you're gonna have a coffee stain on there forever. So I took everything apart, got everything sanded down, and then I needed to make an important decision. Do I go with Danish oil, which is the most neutral of the colors, or do I pick one of these stains? I got 3 options to choose from. They included walnut, mahogany, and dark oak. I was really partial to the mahogany. I love the way this looks. But I did a scratch test, and the stain does not penetrate that deeply into the wood. And I was worried that these scratches over time, knowing myself, these would really bother me. I wouldn't be happy seeing this every day. So in the end, I actually decided to go with the Danish oil. If you look really closely here, you might notice that there actually is a scratch on there, but it's very hard to see, whereas the others are super easy to see. So in the end, I went with the Danish oil. I think it looks great. I love being able to see the natural wood pattern in the desk itself, and I'm happy I did that. And there you have it, folks, my new desk. This project has been a real behemoth. It's forced me outside of my comfort zone. It's forced me to learn all kinds of new things. And I guess that's the whole point of making. You either go deep into subjects that you already know, or you go broad and learn new things. And I feel like I've done a lot of that on this project. I know this has been a long video, so if you're still watching this, thank you for hanging in there with me. If you have any comments, please leave them below. I try to read and respond to as many of them as I can. If you feel like it's earned it, please like and subscribe. And if you're into supporting channels like this on Patreon, well, I would love to have your support. Anyway, thanks again for watching, and I hope to see you in the next one.